tell us a little bit, what is it that Pixel does, right? Where did the inspiration in particular to start Pixel, to take up this sort of, problem statement come from? And then some of the different choices that you've made for the company, right? That you wanted to be a satellite company as opposed to, being something else. The fact that you want to work with hyperspectral imaging in particular, and the different capabilities that that provides you with, right? Tell us also a little bit about how, you all decided that this is the kind of satellite, this is the kind of imaging, this is how we want to monetize, the capabilities that we have. How did you arrive at, some of these design choices for the company that Pixel eventually over time ended up becoming?
Yeah, I mean, look, I think, as I said, after coming back from the Hyperloop competition, just looked around at what was happening, everything from rockets to satellites to downstream applications. So it was, most startups are you find a problem and then you try to solve that problem, right? The industry kind of comes a little bit later. Whereas in my case, I was very clear that I wanted to work in space technology, and then I had to try and find a problem within that could work. And looking at things that were happening, it had to be kind of achievable and tangible for a college student out of India without any money, right? I don't have billions lying around to be able to put in trying to build rockets. And how do you find something that's tangible? How do you find something that I'm interested in, which is anything in space technology domain? And how do I work on something that has actual impact on our planet or impact on humanity? And looking at that, satellite imagery seemed like a very accessible way to get started, at least because there was recently a lot of satellite data that had started to come down, and not enough people analyzing that data using AI or ML. This was back in 2018, 2019. And while working with different kinds of data sets and trying to extract information from them, we happened to stumble upon hyperspectral data. This was a data set that was being collected in very low quantities by NASA, using their drone, or they had one satellite that they had launched, which was experimental in nature. And we are like, okay, wow, hyperspectral data. When you look at a farm with hyperspectral data versus the forms of data that came before, multispectral and optical, there was a wealth of difference in what you could see. Like, for example, if I was looking at a farm with previous images, I could identify that it's a farm, and I could identify if the crop is doing good, bad, or somewhere in between. But I could not identify what species of crop I am looking at, or what nutrient content was present in the soil, or what was the chlorophyll level or the irrigation level, etc. And that is where hyperspectral really shone, where it could help us see these invisible things. Or if I have to take another example, if you're trying to look for minerals in many areas, many things look very similar. This stone looks like that stone, and it's very hard to ascertain it from 500 kilometers away on top of the surface of our planet. But hyperspectral enables us to clearly see this is this mineral, that mineral, because what hyperspectral is in essence is it's taking information in hundreds of wavelengths. Human eyes can only see things in three wavelengths, and hyperspectral satellites and cameras can see things in 200 to 300 wavelengths. And that difference between three, which is red, green, and blue in the visible range for humans or our cameras, 200s is what enables us to see those invisible things. A very crude analogy would be, if I have internal bleeding from an accident and I go to a doctor, doctor won't use a phone camera to see what's right or wrong. The doctor would use an ultrasound scanner or an MRI machine or an X-ray machine. They're all different types of sensing that you're using. And similarly, hyperspectral is a different kind of sensing. So we came across this data set and we are like, okay, let's go and find up-to-date current frequent hyperspectral data that we can buy and start doing analysis. And then we realized that there was really no one in the world that was selling it. Why were they not selling it? Because it was a very nascent technology. It was new. Even the satellite that NASA had launched was not at a level of quality that was needed to make it commercial. And so the opportunity opened up in front of us, which was hyperspectral can help us see so much more, and we needed from satellites to do it globally. No one was doing it globally, and the challenge was you had to push the cutting edge of what was possible to making it better. And so that is how I think Pixel's problem statement specifically came to be, and we
Got it.
started on that journey in 2019. Then, yeah.
Understood, understood. And tell us a little bit about, when you guys started initially, you started on campus before you ended up raising your first rounds of funding, and then, more people came on board. But in the early days when it was just the few of you all, working on campus, what was that like? Curious to know a little bit about the in-college experience
Yeah.
of building Pixel as well.
I mean, it was like another student team. The Hyperloop experience had taught me a lot in terms of, how we kind of self-limit ourselves as students, or even today at any age. We as humans can do a lot more than we give ourselves credit for. And I think that Hyperloop experience really shattered that mirage in a sense, because when we started, I mean, as I said, the entire intention was, okay, will we get an invitation to at least go to LA and be able to glimpse Elon, who used to be an inspiration at that point in time for what he had done with SpaceX and Tesla and all of that. But when we got selected through the first round, then we had to take it a lot more seriously and we had to really get into the weeds of the engineering and the design. Right. So, and then we managed to figure out how to actually build it. And so, college students building something that other engineering organizations also had not in a shorter span of time with much lesser amount of money, and all because we didn't let any doubt come into our mind that, hey, is this even possible? We were like, you know what, this we need to build this. We will go and build this. We just know how to figure out and solve the hundreds of problems in the chain to building this. And when we actually put it all together, it was a very eureka type of moment that, okay, we have done it. And then that gave a lot of confidence that if a hyperloop could be built, a satellite should be logically easier, because there were many people who had built satellites before. There was a lot of material and textbook and papers on satellites that we could read on the internet, none of which was available for the hyperloop. But I mean, obviously, it didn't turn out to be true because it's a much more sensitive and complex machine when you're building a satellite. But I think it kind of worked like a college team. So initially, it was me just going through and scouring what was kind of happening, and then a plan started formulating together. Okay, we will build a constellation of hyperspectral satellites, X number of them. We will use this for these applications. And then I used to play FIFA with a friend of mine called Kshitij in college, and I spoke to him about this idea one of those evenings after the game, and then I asked him if he would sort of like to join and work together on this idea, and then he said yes. And then so we kind of started getting together to just like a couple of hours to 3 hours in the third year of college to sort of see what was happening. And then we were like, okay, I think what we should do is we should create a college team like Hyperloop was. We should go and try to raise sponsorship. We should move down to Bangalore where the ecosystem existed to actually build a satellite. So the initial idea was, can we build a quick and dirty small satellite first and then launch it, and then see what would come out of it as a college team, not as a startup. But then we realized that it was very hard to convince sponsors that a bunch of college students could build a satellite. We went to smartphone companies to tell them, hey, give us money, give us your smartphone, you put it on a satellite, you'll get a money shot of the earth, and you can use that for your ROI as advertisements on newspapers and whatnot. That our cameras can take an image of the planet, etc. But they didn't really buy it for good reason. In a different world, maybe if I was at that age and looking back at college students, I wouldn't either. But I think all that essentially somehow led to a realization that I think it's probably better to do it at a startup. There seem to be a lot of use cases for it. There seem to be a market for it. And if we at least have some angel investors who are willing to take equity, maybe it would be easier than raising a sponsorship. So a few months before the summer vacation of before the final year, I went up and had a chat with a few folks. Manas and Tejasvi, your friend, was kind of one of them. And they were grateful enough to put some trust in what we were doing, and like, okay, we'll come down to Bangalore and we will rapidly prototype a satellite, see where it takes us, etc. So we came down to Bangalore. We had this maker lab under a metro station, which used to shake every time a metro used to pass by. But it was kind of like a very productive summer of 2 to 3 months where we used to just come in the morning, talk about what needs to be done, go prototype something with 3D printing. Almost all of my savings and my dad's savings kind of sort of went into that. But then during that is when we realized that we should probably raise a funding round as a startup. And so we ended up setting up a formal entity in early 2019. And thankfully, I think there were a few angel investors from our own university bits who were willing to look at it like philanthropy. And they were like, if it works great. It's good for bits. It's good for India. It's good for us. But if it doesn't work, this money doesn't really matter to them as much. We were able to put like $700,000 or 5 crores at that point in time, or 4.5 crores at that point in time, together to do what we wanted to do. So that's what the college days were like. Very chaotic, very
Mhm,
un,
mhm.
but at least we were like, we have to get this done, and we were passionate about it.